Okay. So yesterday we learned a lot more about parabolas. We learned they came from a definition. They've got more interesting features than just a vertex and whether they open up or down, stretched and shrunk and stuff like that. In fact, from the definition, we came up with a new format for like a graph-friendly form, and we can make a parabola that opens up, down, left, or right, any one of those. And we also learned how we can tell the difference between a parabola, a circle, an ellipse, and a hyperbola. So we had these examples up here, and what we spotted was if it's got one squared variable, it's got to be a parabola. That's the easiest one to spot. If it has two squared variables, then we've got to check a couple of other things. If they have exactly the same coefficient, it's a circle. If they have the same sign but different coefficients, then it's an ellipse. And if they have different signs, it doesn't even matter what the coefficients are. As long as they have different signs, then we know that it's a hyperbola. And again, it had to be in general form. That means everything is on one side, at least all the variables are on one side. And then we went through, we identified what a couple of these were. We went through and used the definition to create the equation. So here was one graph-friendly form of an equation of hyperbola. And there was another one. And then what was the fun word we learned yesterday? Oh, rectum, just rectum. Very nice. Okay, it's called the Latus Rectum. Okay, and we end up graphing the endpoints of the Latus Rectum, or we can call it LR for short if you want to label those. Okay, we end up labeling those points. So we're going to graph the directrix, the focus. Those are the things that come from the definition. And then the vertex, and then the two endpoints of the Latus Rectum that are on the parabola. And we're all set to go. We've got the whole thing. So we graphed a couple that opened up, a couple that opened to the right. And the difference between this line and this line up here was we took the same shape. We just moved it around using some of those techniques that we talked about before. And then we kind of summarized and said, you know what? If it's x squared, it's going to either open up or down. And you're going to tell whether it opens up or down by whether it's positive or negative, whether that 4a is positive or negative. And then again, I warned you about this. Always make sure that you're finding the x and writing down the number with the x, or the opposite of that number, as the x coordinate of the vertex, and the opposite number with the k as the y coordinate of the vertex. Okay? And then another thing that we want to make sure that we're careful of is a is a distance. The a is always positive. A is always positive. The sign tells us which direction it opens, but the a is just a distance. Okay? So we did this problem right here, and I said, you've got enough information that you can go home and do nearly all of the problems. Not all of them, but most of them. How many of you got started on the assignment? One. Okay, here's the problem. You get this far along in math, and everything you learn every day is complicated enough that all by itself is enough to overwhelm your brain. We're going to finish this, and then we're going to start doing ellipses. And ellipses are different than parabolas. So if you don't have parabolas straight in your mind, it's pretty tough to figure out ellipses. And the same thing's going to be true. So if you're always a day behind getting started on stuff, it's going to make these more difficult to learn. Now, Bossard may have given you a ton of homework. Doesn't matter. You still have this class.
We have 2 history tests tomorrow.
Very nice. Very nice. Better make sure you understand this, because we're going to have a test on it in, I think, about 2 weeks. Okay, so let's take a look at example B on this one. It says we've got a vertex at 3, 2, and the directrix is x equals 1. So they're giving us the vertex. That's a lot of information right there. We know that with the x is going to be a -3, and with the y is going to be a -2. But let's just kind of sketch this out and see roughly what we're looking at. We've got 3, 2 right here. There's the vertex. And then the directrix is x equals 1. Well, x equals 1 is this line right here. Remember, the focus is always inside the curved part of the conic section. The parabola curves away from the directrix, so we're looking for something that looks like this. That's enough information right there to set up most of the equation. So this is going to be which variable squared? Y is going to be squared. So we're going to write y minus 2, quantity squared. I'm going to leave a space here to put the 4a stuff, and then this is going to be x minus 3. And I need to figure out what number goes here. The number that goes there is going to be 4a, either positive 4a or negative 4a. Is it positive or negative? Positive. Why? Because it opens to the right. Okay, so we know that's going to be positive. How do we tell what a is? It's a distance. It's the distance from the directrix. Let me change colors here. It's the distance from the directrix to the vertex and from the vertex to the focus. So that distance, if this is x equals -1 and this is the point 3 comma 2, how far is it from 1? Sorry, did I say -1? It should be +1. How far is it from 1 to 3? 2. So that means our a is going to be 2. So what number goes here? 8. That is the answer. Okay? Again, you have to know all the parts of a parabola: directrix, vertex, focus. It may give us the endpoints of a latus rectum at some point. And there we go. Okay, any questions? Okay, next part says, find vertex, focus, and directrix for the given equation of a parabola. Does it say graph it? Doesn't say graph it. Now, just because it doesn't say graph it doesn't mean graphing it wouldn't be a helpful thing to do. So let's think about what shape this is. First of all, which way does it open? Opens up. Where's the vertex? 0, 0. So we're looking for something that looks like this. 4a is equal to 4, so what's a? A is equal to 1. Now, it wants the vertex. Vertex is pretty easy, 0, 0. It wants the focus. If you know the vertex is at 0, 0, and the focus is always inside the curved part of the conic section, we're going to go how far inside here? 1 unit. So we're going to be right there. So that's going to have the same x coordinate, different y coordinate. So the focus is going to be 0, 1. And then it says, where's the directrix? Remember, the directrix is outside, curves away from the directrix. So we're looking at something right here. And what is it? Y equals -1. Any questions there? Okay, think about that next one. Vertex is easy, right? 0, 0. Which way does it open? Opens to the left. So we're looking for something that looks like this. Okay. What? Okay. The y-squared tells us it opens left or right. The negative tells us that it opens left. The next thing we need from this is, now, do I need to say 4a equals -12 and then solve this and say a equals, would I say a equals -3? No. Remember, that negative tells us which direction it opens. A is always a distance. It's got to be positive. So that means we're going to go 3 units inside here to get to the focus and 3 units outside here to get to the directrix. If I was at 0, 0, the focus would be at -3, 0, and the directrix would be x equals 3. X equals +3. Any questions there? Sure? Graph the following and label important parts. Okay. Yeah. Okay, because this point right here is 0, 0, and I've got to go 1, 2, 3 units away from the vertex to get to the directrix. So this distance right here is 3 units, just like this distance right here is 3 units. So if I was at 0, 0 and I backed up 3 units, that's why this is -3, 0. If I went forward 3 units, that point right there would be 3, 0, but I'm not interested in the point. I'm interested in this vertical line right here. So the same distance away from the vertex as the focus. Yep, always. Okay, the vertex is always smack dab in the middle of the focus and the directrix. It's on this straight perpendicular line from the directrix to the focus. The vertex is always right in the middle of that. Okay? Any questions? How long would the latus rectum be on this? No, this one right here. It's this number right here. No? The latus rectum is 4a. How long is the whole thing? It's that number right there. It would be 4. You'd go 2 in each direction. How long is the latus rectum on this one? 12. How far do you go in each direction? 6. You with me there? Okay, so let's...
Why do they call it that? Why can't they have a better name for it?
Because they knew you'd ask. Okay, so let's take a look at this one right here. This one opens up. Vertex is at 0, 0. What's A? A is 2. So we're going to go up 2. There's the focus. We're going to go down 2. There's the directrix. I want to graph 2 other things on here, and then I've got everything I need to make the right shape. What else do I need to plot? The 2 endpoints of the latus rectum. How long is the whole latus rectum? 8. How far do I go either direction? 4. So 1, 2, 3, 4. 1, 2, 3, 4.
You don't go from the origin, you go from the focus point?
Yeah, the latus rectum goes straight across the focus. Okay, now, does anybody recognize that? It is. It happens to be the very first one we did yesterday. How long did that take? It took a long time yesterday. It took maybe 20 seconds here. Now we ought to label this. The focus is going to be 0, 2. This endpoint is going to have the same y coordinate, so it's going to be something comma 2, and that one's going to be something comma 2. I went over 4, so that'd be 4, 2, and this would be negative 4, 2. The vertex is 0, 0, and the directrix would be, please don't screw this up, it's a horizontal line, so it's going to be y equals a number. It's y equals negative 2. That literally takes to graph this, once you know how parabolas work, and you know all those pieces and parts and names and everything, maybe 45 seconds and you've got a decent sketch. So let's do this one. Which way does this open? Opens to the left. Where's the vertex? 0, 0. And if it opens to the left, all I need to know is I'm going to curve this around here to the left. What's A? A is 1. Positive 1. Remember, A is a distance. So I'm going to go 1 unit here and 1 unit out here, and this is the directrix. I need 2 more points and I can graph the whole shape. Okay, it's been like 30 seconds and I'm yapping the whole time. We nearly have this done. How long is the entire latus rectum? 4. How far in each direction? Just 2, so we're going to go from here to here. Draw the shape. Label everything. So the focus is going to be negative 1, 0. Vertex, not much room there, so I'll write it up here. Directrix, x or y? X equals positive 1. And then I want to label these things right here. I want to label the endpoints of the latus rectum. What do they have in common with the focus? What is it, Justin? Same x coordinates. So negative 1 here and negative 1 here. We went up 2, so this would be 2. We went down 2, so that would be negative 2. Okay, any questions? It's pretty fast, isn't it? Once you get the idea? Okay, good there? Okay, let's take a look at this one. These get a little bit more interesting, and then we're going to do ones where they describe it, and we have to come up with an equation. A little bit more difficult than the other one we did there. Okay, take a good look at this. Vertex. Careful, be careful. Find the x, so it's going to be negative 3, positive 2. So negative 3, positive 2, so we're right here. Think for a second. Next thing we want to do is, I've identified h and k correctly. Now I need to look at this and figure out, hey, this is y squared, and it's got a negative here. Which way? This is going to go left. What's A? 3. A is equal to 3. So I'm going to go 3 units here and 3 units back here. So this is the focus. This is the vertex. Here's the directrix. And I need 2 more points. Look at that. There's hardly any work to do here. You just look at it and you know what's going on. How long is the latus rectum and how far do we go in each direction? 12 and 6. So we're going to go down 6. It's going to put us about right here. Up 6. That's going to put us about right here. Now, even if this is off the graph a little bit, as long as we label correctly, we're in good shape. Okay. You can watch up here just a second. I'll give you time to fill it in just a minute. Okay. What's the equation for the directrix? 0. Vertex? -3, 2. Okay. Focus? Okay, we went back 3 more, so this would be -6, 2. What are these 3 points going to have in common, Justin? Same x-coordinate. And we went up 6, so that's going to be, -6. We went up 6, so that's going to be 8. And we went down 6, so that's going to be -4. Does everybody understand that? Are there any questions at all? Okay, you do that one, please. Okay, that should be enough time where you may have a question about, hey, wait a minute, this looks a little weird. What's different about this one? Doesn't have a thingy out front in the Y, right? Remember, we said this always had to be factored, correct? This needs to be factored. You can take out a 1. If you wanted to park a 1 out in front there, that's fine. If you wanted to just assume it's there, that's okay. It's a positive 1. What does that tell us about this parabola? Okay, x squared, and the fact that it's positive means it's going to open up. Where's the vertex? -1. Again, look for the x. Don't always assume it's first. In this case, it is. So it's going to be -1, 1. So we're right here. There's the vertex. What's A? A is 1/4. Okay? A is 1/4. So that means I'm going to go 1/4 of a unit up here, and there's the focus. I'm going to go 1/4 of a unit down there, and there's the directrix. So if the vertex is -1, 1, and I went down 1 unit, what's the equation for the directrix? Y = 3/4. Y = 3/4. With me there? If the vertex is at -1, 1, and I went up, how far? 1/4 of a unit to get to the focus. Where's the focus? Okay, -1, 5/4. Then all I need to do is get the endpoints of the latus rectum, and I'm set to go. The whole thing is 1 unit long. You just look at that. There's the length of the latus rectum. We go half that in each direction, so that's going to be half a unit over here and half a unit over here. So here's what that looks like. And we'll label those last 2 points. So this would be, let's see, that's even with the latus rectum height-wise. So what do these 3 points all have in common? 5/4 for the y coordinate. 5/4 here and 5/4 here. If I was at -1 and I went forward a half, -1/2, and this would be -3/2 if we wrote it as an improper fraction. Okay, are there any questions there? Of all the parabolas that we've graphed, this is probably the most normal looking, isn't it? Yeah, because it's got that classic shape to it. The other ones all seem to have been kind of wide. So what that means is on those really tight parabolas, the ones we're used to working with, the focus would be really close to the vertex. The wider it is, the further away from the vertex the focus can be. And we'll talk about that a little bit more in just a second. So go ahead and flip the page over. And let me see. Here we go. Okay, it says find the vertex focus directrix for the given equation of a parabola, then graph the parabola. What's wrong with those? Okay. They're not factored, they're not in a nice graph-friendly form, so we're going to have to put it in a graph-friendly form. Now, you'll remember that when we went over completing the square, I said, hey, you need to know how to do this. It wasn't our favorite technique for solving a quadratic, but you can't forget how to complete the square because you have to know it for these sections right here. So on this problem right here, you'll think back, the way that looked is x minus h quantity squared equals 4a y minus k, or change the h and the k and the x and the y so we could square the y and so forth. Each one of those has a perfect square in it. To get it in that graph-friendly form, you're going to have to complete the square. So here's what we do. It's similar to the process we used before. I'm going to collect the x's together. So I'm going to do x squared minus 4x, and I'm going to move everything else to the other side. So if I move that to the other side, that's going to be a 4y plus a 4. I want to complete the square with this. Luckily, this has a 1 out front. Remember, you can't complete the square unless it has a 1 there. So I can take half the middle coefficient, square that, so that's going to be add 4. If I add 4 to this side of the equation, what do I have to do to the other side? Got to add 4 there. Okay, so that blue stuff was not in the equation to begin with. But now this makes it so I can write this as, this is going to be x minus 2 quantity squared. And this is, let's see, this would be 4y plus 8. Am I going to write 4y plus 8 over here? Nope. What are we going to do? 4. Okay, it's got to be factored. It's got to look like this. So this is going to be 4 and y plus 2. Once we get it to there, it's just like the equations that we got done graphing a second ago. What's h? 2. What's k? Negative 2. So over 2 and down 2. So there's our vertex. We know this opens up. What's a?
1.
A is 1. Okay? So this means a is equal to 1. So I'm going to go up 1, and that's the focus. I'm going to go down 1, and here's the directrix. And if I put those 2 other points on here, I'm in business. How long is the whole thing? 4. How far in each direction? Just 2. So I'm going to go over here and over there, and I'm going to let you label it. So go ahead and label those 4 points on the parabola plus the directrix, or 4 important points about the parabola. Okay, we got it? These 3 points are right on the same horizontal line. They all have the same y coordinate. So I went forward 2, that's going to put me at 4. I went back 2, that's going to put me at 0. Any questions? Sure? Okay, let's take a look at the next one. This one's a little bit unique. Not in graph-friendly form. Save room to complete the square, move that to the other side. Half the middle coefficient is positive 1. Square it. I'm going to be adding 1 here, which means I need to add 1 there. And then we're going to write it in the graph-friendly form, and that is y plus 1, quantity squared. Factor out the negative. If you want to write it as negative 1, that would be fine. Then you can see, hey, that's what 4a is. And then this is x minus 1. Vertex. I heard a couple negatives first. Okay. Find the x. That's what the h is. So we're going to have a 1, negative 1. Okay. Again, if you're not paying attention, I guarantee somebody's going to make that mistake on the test. So our vertex is at 1, negative 1. A is 1/4. Okay? So this is a fairly realistic shape. And which way does it open? Okay. Notice that it's, oops, let me make this a tad smaller. Okay, notice that negative there and y is squared, so this is going to open to the left. So I go 1/4 of a unit here to get to the focus. I go 1/4 of a unit here to get to the directrix. And if the vertex is right there at negative 1, 1, this is going to be x equals 5/4. That focus, draw it out here. That focus is going to be at 3/4, negative 1. And then I'm going to go how far in each direction? Just a half, up here and down here. So the graph looks like this, really tight and compact parabola. And then I'd label these points right here. They'd both be at 3/4, comma something. One was up 1, so that'd be a negative half, and this would be negative 3/2. Okay, any questions? These pretty easy? Okay, good. Okay, let's take a look at a couple problems. I actually put these 3 problems on another page so we could see what they were. So here's number 12. And I put this on every single one of these, so you might as well catch it now. There really is no substitute for going through, figuring out how these work, doing a lot of practice so you're sure you can keep them straight. You know, oh, I'm dealing with a parabola, and you immediately know what formula you're working with and all that sort of stuff. So let's take a look at number 12. What do you notice about that? And can we pick out the answer here pretty quickly? Or could we at least eliminate some of them? Y squared, negative. It's not any of these, right? Okay. So it's got to be a y squared, so we can cross out these right here. And it opens to the left. Got to be that one. Okay. In each section, they'll give you some conic sections, and they'll say, hey, which equation would have to correspond to this? Okay. So let's take a look at another one. This one says find the equation, then graph and label completely. Vertex is at 4, negative 2. Focus is at 6, negative 2. Now, this does say graph, so we're not wasting any time or effort if we go ahead and graph this. 4, negative 2, so 1, 2, 3, 4, and down 2. That's where the vertex is. And then the focus is at 6, negative 2. The vertex is on the parabola. The focus is always inside the curved part of the conic section. Which way? Oh, got to open to the right, okay? So it looks like that. Now, from this, if you know this is the vertex, you know that's H and K, but you've got to figure out which direction it's headed so you know, do you do y squared or do you do x squared? In this case, we're going to do y squared, so this is going to be y plus 2 quantity squared. I'm going to leave that blank for just a minute, and then I'm going to write x minus 4. So I need to figure out, is this 4a or negative 4a? Which is it? 4a. It's going to be positive, right? I'll just put that there as a reminder. Okay, and it's just 4a. So how do you figure out what a is? This distance. How far is it if we're right here at 4 and then we're over here at 6 to get to the focus? What's a? 2. So what number goes here? 8. Okay? We should label a couple of other things on this because it did say graph it. What else should we label? We should label the directrix and a couple of points. So we're going to put a point here and a point here. The directrix is going to be over here. If this is at 4, this is going to be x equals 2. This is 6 comma negative 2. And how far would I go up and down? 8 altogether, 4 in each direction. So this is going to be 6 comma 2, and this is going to be 6 comma negative 6. Any questions? Needs to be second nature. Okay? Needs to be very fast. All right, let's take a look at this last one. It is x squared. And it's negative. Okay, and there's our h and there's our k. So I'm going to do x minus 1 squared, y minus 2. Negative in there. Would we just want to assume that these are the endpoints of the latus rectum? Did they tell us where the focus was? Nope. Any ideas on how we figure out what A is? The whole thing is 2. That's from side to side, but we don't know that the focus is right there. The focus could be here, it could be out there, it could be a lot of different places. So because they didn't tell us, we have to go back to something that a lot of you were in my 1010 class. I said, please don't forget this, because even calculus students forget this, and it's a really useful fact. That point right there, 2, 1, is on the graph. There we go. If it's on the graph, it's got to work in the equation. So the only thing missing here, if I plug in that for x and that for y, is what A is. So let's go ahead and do that. 2 minus 1 quantity squared minus 4a, and this would be 1 minus 2. Solve that and we'll have what A is. So this is going to be 1. This is going to be negative 1 times negative 4, so this is 4a. So that means A equals 1/4. Now, is that the answer? No, because you come back up here and plug it in. So what's 4 times A? It's going to be 1. So x minus 1 quantity squared. This is going to be a negative 1. Again, if you just wanted to write the negative, that would be fine. But there's the right equation. Okay? You really have to think about this. If you're going to get problems like that correct, you're pulling together a lot of the stuff that we've already studied. Okay? Any questions? Got parabolas figured out?